Welcome to the Deep Dive. We're the place where we try to, cut through the dense academic stuff and get right to the core of some truly big ideas.
Ideas that really make you rethink things.
Absolutely. And today, we're diving into something seriously mind-bending. We're asking, what if everything we thought we knew about the universe, the basic rules, the constants, particles, forces, what if all that is just like the surface?
Just the visible part of something much, much deeper. A hidden structure underneath it all.
Exactly. A universe that isn't just described by physics, but maybe generated by it.
It's a huge question. It really challenges our most basic assumptions about, well, everything.
Yeah.
Existence itself.
We're talking about peeling back the layers of reality, basically,
Yeah.
trying to see the engine underneath.
And I think as we go through this, you're going to have some real aha moments. It connects a lot of dots.
I think so, too. This deep dive is all about a pretty revolutionary new framework. It's called the Unified Coherence Theory of Everything, or UCTE for short.
Right.
And our main source today is a really significant paper by Philip Randolph Lilien. It's titled Spin, Coherence, and Vacuum Dynamics: Bivector Reduction, Eigenvalue Thresholds, and Emergent Physics. Quite a mouthful.
It is, but it lays out a radical reformulation of physics. It doesn't just tweak the current models. It's just a whole new blueprint.
Yeah, that's the key. Our mission here is to unpack this paper, really get into the details, and explore how UCTE challenges, the standard way of thinking.
And how it offers what Lillian calls a generative explanation for things we usually just take as given. Axioms, mysteries.
Right. Things physics describes but doesn't always explain the why behind. So instead of just the what, UCTE tries to explain why reality is structured the way it is.
Exactly.
So get ready, because we're going to explore what Lillian presents as a unified, surprisingly intuitive picture of reality. It pulls together different fields of physics.
Fields that often seem totally separate.
And it even hints at
Phenomenally so. But often, the fundamental why isn't really addressed. Spin is just called an intrinsic property. It just is. Forces are just kind of given. Constants are numbers we measure, plug into equations, but we don't have a first principles reason for why they have those specific values.
values that often seem really finely tuned for life and complexity to even exist.
Precisely.
Yeah.
So standard physics is great at the what and how, but it often stops short of explaining the ultimate why. It's predictive, but maybe not fully explanatory at the deepest level.
Okay, so we're good at describing the symptoms, you could say, but UCTE wants to understand the underlying cause, the genetic code of the universe, maybe.
That's a really good way to put it. And the leap UCTE takes is into generative physics. It proposes that reality has the structure it does because everything we observe, particles, forces, constants, even space-time itself, emerges from a deeper, more fundamental architecture.
So things like particles and nuts aren't the absolute basement level of reality.
In this view, no. They're derivatives. They're outcomes, results, generated by this underlying structure. Lillian talks about inverting the usual hierarchy. What we think of as fundamental might actually be emergent.
Wow. Okay, that is a huge shift. It's like the universe isn't just following a recipe, it's generating the ingredients in the recipe itself from something deeper.
Exactly.
So what is this deeper architecture, this generative substrate?
That brings us to the core concept of the coherence vacuum.
Okay.
Now, this is crucial. It's not the conventional idea of empty space. In quantum field theory, empty space isn't truly empty. It's this sea of virtual particles popping in and out of existence, quantum fluctuations.
Or quantum foam.
Right. But the UCTE coherence vacuum is something very different. It's described as a dynamic, highly structured, hyperfractal substrate.
Hyperfractal. Okay, unpack that for us. Fractal I get, like Mandelbrot sets, patterns repeating at different scales. What does the hyper add?
Good question. So think beyond just spatial scaling. A hyperfractal structure implies self-similar patterns in organization, not just across different sizes, but across dimensions of, say, information, coherence potential, and complexity.
So it's fractal in more ways than just geometry.
Exactly. It suggests that the deeper you probe this vacuum, the more intricate, structured, and information-rich it becomes in multiple interconnected ways. It's not just repeating shapes, but repeating organizational principles, potential states, coherence patterns. It's incredibly rich.
So definitely not empty. It's more like a blueprint or maybe even the loom weaving reality.
That's a good analogy. Lillian describes it as a structured field defined by resonance harmonics. It's full of latent potential. It's the foundational layer underneath space-time. Maybe the ether people used to search for, but dynamic and structured, not just a passive medium.
Okay, so this active structured vacuum, How do we describe it? Is there math for this? Yeah.
Yes, that's where the vacuum coherence tensor, written as V mu nu, comes in. Lilien introduces this as the key mathematical tool. Think of it like Einstein's field equations for gravity, but instead of describing space-time curvature due to mass energy,
It describes.
it describes the distribution of coherence, the resonance dynamics within this vacuum substrate, how it organizes itself, how symmetries emerge, how energy is distributed within it. It's like the master equation for the vacuum's internal dynamics.
The operating system of reality, maybe?
You could think of it that way, yeah. It encodes the potential for everything else.
And then there's hypergravity. That sounds important, but you said it's not regular gravity.
Correct. It's distinct from the gravity we experience as spacetime curvature or Newtonian attraction, although it underpins them. Hypergravity is described as the invariant coherence attractor stabilizing the vacuum lattice.
Okay, stabilizing force.
Right. It acts as a fundamental background stability operator. It's what keeps this dynamic vacuum lattice from just, falling apart. It ensures the underlying structure holds.
So it provides the baseline stability.
Yes, and it governs how latent energy is distributed and how symmetries get locked in within the vacuum. Lilien connects it to something called omnilectic invariance.
Omnilectic invariance. That sounds profound. What does that mean?
Think of it as the highest level of symmetry, the ultimate unified state. It's a state of pure potential before anything differentiates, before forces split off, before particles form, before dimensions as we know them emerge.
Like a perfectly balanced, undifferentiated potential.
Exactly. Omnilectic suggests all possible modes or logics are present, but in a perfectly coherent, invariant state. Hypergravity maintains this foundational invariance, this stable potential, from which everything else then reduces or emerges when symmetries break.
So the coherence vacuum is the medium, Vin describes its dynamics, and hypergravity keeps it stable and coherent at the deepest level.
That's the basic picture, yes.
But how does the stable dynamic substrate actually generate things? How do we get from coherence to, say, the frequency of light or the energy of a particle?
That leads us to a really crucial distinction UCTE makes. It's fundamental to everything else, the difference between resonance and frequency.
Okay. Usually we just talk about frequency, right? Cycles per second.
We do. In standard physics, frequency is the measure of oscillation over time. We measure it. It characterizes waves, particles.
But the UCTE says that's not the whole story. Or maybe it's just the surface level.
Exactly. Lilien puts it very pointedly. Resonance is the cause. Frequency is the shadow.
Wow. Okay.
So frequency, in this view, isn't the fundamental thing. It's the temporal projection of that resonance onto a measurable axis. It's what we see when a deeper resonance projects into our familiar space-time dimensions.
And resonance itself is?
Resonance is defined as a coherence relationship between field nodes. It's the deep underlying harmonious relationship, the alignment, the phase locking between different aspects of the coherence vacuum itself. It's happening in that deeper, possibly higher dimensional structure.
So the frequency we measure is like the shadow cast by this deeper hidden relationship.
Precisely. It's the visible trace of hidden coherence relations. Think of music again. You hear a note, that's the frequency. But the resonance is the complex interplay of the string, the instrument's body, the air, the whole system vibrating in harmony to produce that note.
Gotcha. So if we only measure frequency, we're missing the real action, the underlying cause.
That's the argument. You have to consider the underlying resonance to understand the primary structuring dynamics. This implies that stable structures, like particles or energy levels, correspond to these stable resonance plateaus, places where the vacuum modes phase lock. The frequencies we measure emerge from that locking.
Okay, that resonance versus frequency distinction is huge. It really changes how you look at, well, everything. If the vacuum is resonating, the next logical question is, are there specific stable resonances, like preferred notes the universe likes to play?
That's exactly where Lilien goes next, with the coherence eigenvalues. He calls them the universe's fundamental tuning forks.
Tuning forks, I like that. So what are they exactly?
They're denoted Lin, London, and defined as stable resonance plateaus in the coherence vacuum. These are the specific configurations where the vacuum's coherence becomes particularly stable, where it phase locks into specific geometries.
So they're not just random numbers, they emerge from the vacuum itself.
Yes, they arise directly from the phase locking conditions described by that vacuum coherence tensor again. They represent these vacuum locking events, Think of them as the universe settling into its most stable, harmonious configurations.
And these stable points, these eigenvalues, they then dictate.
They govern pretty much everything fundamental. The constants, the forces, even the way atoms are structured, like electron shells.
Wow.
And they're not isolated. Lilien describes a resonance cascade where coherence from potentially higher dimensions reduces down, locking into these nested eigenvalue attractors one after another. This cascade is what manifests the physics we see.
A cascade generating reality. Okay, let's get specific. The paper talks about particular eigenvalues. The first one is U1 11137. That number jumps right out.
It should. It's instantly recognizable as the approximate value of the fine structure constant, alpha.
The strength of electromagnetism, a number physicists have puzzled over for a century.
Exactly. In standard physics, alpha is this dimensionless constant, measured incredibly precisely but fundamentally unexplained. Why 1137-ish? It seems arbitrary.
But UCTE says it's not arbitrary.
Not at all. It says this EU1 eigenvalue is the origin of alpha. It's the first major lock-in event in the vacuum's resonance cascade. This specific vacuum resonance sets the strength of the electromagnetic interaction.
So alpha isn't just a number, it's a measure of a fundamental vacuum resonance.
Precisely. And it doesn't stop there. This eigenvalue, this resonance, directly determines the Bohr radius, the size of the simplest atom. It sets the scale for the K shell, the innermost electron shell. It basically defines the entire electromagnetic scaffolding for atomic structure.
So the very size and stability of atoms comes directly from this vacuum lock-in. That takes alpha from being a mysterious number to being a cornerstone derived from something deeper.
Exactly. It's emergent, not just empirical. It feels much less accidental.
Okay, what's the next step in this cascade? The next eigenvalue.
That's SU2, 8.125, or 1/8.
SU2, symmetry. That makes me think of electron spin and the weak nuclear force.
You're right on track.
Yeah.
This SU2 plateau is crucial for several things. First, it stabilizes spin phase topology. Specifically, it's linked to that weird four-periodicity of spin half-articles, the 720-degree rotation we'll talk more about.
Okay, so it governs that fundamental spin behavior. What else?
It also sets shell capacity and Pauli stability. It plays a key role in how electrons arrange themselves in shells beyond the first one, underpinning the Pauli exclusion principle. And as you guessed, it defines the symmetry structure associated with the weak interaction.
And the paper links this to isospin, too. That's usually deep in nuclear physics territory.
Yes. UCTE reinterprets isospin, the symmetry that relates protons and neutrons, not just as a nuclear property, but as proton-neutron coherence, emerging from subtle phase relationships within this SU2 coherent structure in the vacuum.
So it's linking the vacuum structure, spin properties, and nuclear physics.
It is. It suggests isospin arises from how the underlying bivector spin topology, which we'll get to, relates to nuclear symmetry and even quark phase alignment through this SU2 resonance. It's a spin phase locking threshold.
That's weaving together a lot of threads. Okay, next up, is UC3 a 0.333 or 1/3 strong force, quarks?
Bingo. This SE3 plateau governs strong spin coupling and exchange phenomena. This is the domain of the strong nuclear force, quantum chromodynamics, QCD. It's linked directly to quark confinement, why quarks are always bound inside protons and neutrons.
So this eigenvalue dictates the rules of the strong force.
It dictates the fundamental coherence patterns that manifest as the strong force. It also influences things within the atom, like inner shell shielding and resonance stability, affecting how nuclear charge is felt by outer electron and playing a role in nuclear shell stability. It's tied to strong force coherence.
So the implication here is huge. The relative strength of the forces why electromagnetism is weaker than the strong force, for example, isn't some random cosmic dice roll.
According to UCTE, no. The hierarchy of forces, their different strengths and ranges, emerges naturally from this cascade of discrete coherence plateaus in the vacuum. They are consequences of these fundamental vacuum resonances, these universal coherence tuning points, not arbitrary parameters set at the Big Bang.
That makes the universe feel a lot more structured, less like a collection of random rules.
Exactly. These eigenvalues are the stable points where the vacuum geometry locks in, and those locked-in geometries dictate the physics we observe. It's a very elegant picture.
Okay, this is where things get really, really interesting for me. Part 3. Spin. UCTE claims spin isn't intrinsic, it's projected. Spin in standard quantum mechanics. It's always felt a bit magical, hasn't it?
It really has. It's usually introduced as just this fundamental intrinsic property particles just have, like charge or mass. We assign it a value. Usually as an axial vector, it has specific quantized values.
Plus a half minus a half.
Right. But why? Where does it come from? Standard QM doesn't really say. It's axiomatic. We accept it because the math works beautifully and matches experiments, but the origin is murky.
And then there's the really weird part, the 4 periodicity. The fact that you have to rotate an electron 720 degrees 2 full turns to get it back to its original quantum state.
That's always been a head-scratcher. In our everyday world, 360 degrees brings you back home. Why 720 for quantum spin? It feels deeply counterintuitive.
It feels like someone just wrote that rule down. But UCTE says, hold on, there's a reason it's geometry.
Exactly. It aims to demystify it completely. UCTE proposes something radical. Spin is not an intrinsic property of the particle itself. Instead, it's the observable projection of an internal coherence bivector residing in the vacuum substrate.
Okay, wait. Internal coherence bivector. Let's break that down. What's a bivector here?
So think in terms of geometric algebra. A bivector isn't a vector, like an arrow pointing in a direction. It represents an oriented plane. Imagine a small oriented disk or loop in this hidden vacuum substrate.
Okay, a plane, not a point spinning.
Right. An oriented plane of internal coherence. This hidden geometric object, this plane within the vacuum, is the underlying reality of spin, its orientation, its dynamics. That's what generates what we measure as spin. Mathematically, it's like B where B squared is met as 1, indicating its rotational plane-like nature.
That already feels more physical somehow, a geometric origin rather than just an abstract property.
It does. And this geometric picture leads directly to the rotor formulation. A rotor, mathematically, is basically an operation generated by this bivector. It represents rotation within this internal coherence plane.
The engine of spin, the paper calls it.
Exactly. And here's the kicker. This rotor formulation naturally explains the 4 periodicity. Rotors in geometric algebra inherently double cover rotations in 3D space. This means that rotating the internal state by 360 degrees results in r plus 2 plus 2. You get the negative of the original state.
Ah, so you need another 360 degrees to get back to the positive original state.
Precisely. A full 4-pore 720 degrees. It's not a weird ad hoc rule anymore. It's a direct mathematical consequence of spin originating from a bivector generator. It just falls out of the generator.
That's genuinely elegant. It takes this deep quantum mystery and just resolves it with a clear geometric picture. Okay, so we have this internal bivector, this rotating plane of coherence described by the rotor. How does that connect to the spin vectors that we actually measure in experiments?
That connection is made through the observable spin vector projection. There's an equation, S equals 2 Re3R. It looks a bit technical, but what it does is show how the internal rotor state gets projected onto a specific measurement axis, represented here by E3, like the z-axis, to give us the familiar spin vectors that points up or down.
So it translates the internal geometric state into the directional spin we detect.
Exactly. It bridges the gap between the hidden internal coherence dynamics and the results we get in our labs. It's how the bivector makes itself known in our measurable reality.
Okay, that makes sense. But what about the act of measurement itself? This is where standard QM brings in wave function collapse, which is another notoriously fuzzy concept. How does UCTE handle measurement? You mentioned the ARO.
Right, the asymmetry resonance operator, or ARO. This is UCTE's mechanism for measurement, and it's a profound reinterpretation of collapse. The ARO isn't passive. It's an operator that actively induces coherence reduction.
Coherence reduction, not collapse.
Yes. When you set up an experiment to measure spin along a specific axis, say A, this axis also corresponds to a bivector, AAYIA. The arrow then acts like a projector. Mathematically, it's like PABO. It forces the internal coherent bivector B to interact with the measurement axis bivector A.
And this interaction gives us the probabilistic outcomes, spin up or spin down.
Precisely. This projection process naturally yields the Born rule probabilities, PCT equals 12 Korea, where n is the direction of the projected spin vector. And the outcome settles into one of the 2 discrete eigenvalues. Setting into...
Okay, but how is this different from collapse? It sounds like the state still snaps into one outcome.
The difference is in the interpretation of what's happening. In standard QM, collapse is often seen as this instantaneous, mysterious, non-local event where the wave function just vanishes into one state.
Yeah, it feels very abstract and non-physical sometimes.
UCTE reframes it entirely. It's not a mysterious collapse, it's a phase-locking event within the coherence field. It's a geometric process. The internal coherence plane, the bivector, is forced by the measurement interaction, via the ARO, to align or anti-align with the measurement axis.
So it's a physical alignment, a geometric resolution.
Exactly. The ARO converts the continuous internal dynamics into one of the discrete external projections allowed by the interaction. It's definite, geometric, and grounded in the vacuum structure, not some abstract mathematical jump. Feels much more physically intuitive.
That geometric view of spin and measurement, it really does feel more intuitive, less, spooky, which actually brings us perfectly into part 4, entanglement and spin couplings. Let's tackle entanglement first. Einstein famously called it spooky action at a distance. How does UCTE get rid of the spookiness?
It does it by sticking to that geometric foundation. UCTE offers a straightforward interpretation. Entanglement as a geometric splitting of a shared coherence bivector.
Shared. So the entangled particles aren't really separate entities communicating instantly.
Not in the way we usually think of communication. Instead, they originate from and continue to share a single underlying coherence bivector. Let's call it B12. Think of creating an entangled pair like folding a single sheet of paper. The two ends might seem separate, but they're intrinsically part of the same original geometric object.
So their fates are linked because they were born from the same geometric structure in the vacuum.
Precisely. They share the same internal coherence plane. So when you measure one particle, say particle A, the ARO interaction forces a specific resolution, selecting one vector state from that shared plane.
And because the other particle, B, is part of the same shared plane.
Its state is instantly constrained to be the correlated complementary vector. There's no signal traveling between A and B. It's the simultaneous resolution of a single pre-existing shared geometric codate.
Like figuring out one end of the folded paper tells you something about the other end instantly because it's the same paper.
Exactly. And the standard Bell correlations, the mathematical expression EA, that quantifies entanglement, Lilien says it drops out naturally from the single shared plane. No skooky action, just coherence splitting. It preserves locality because the correlation was inherent in the shared geometry from the start.
That is a genuinely elegant solution to a century-old puzzle. It turns spooky action into just shared geometry.
Okay, so what about other ways spin interacts? Spin couplings? Particles aren't usually isolated, right? And these interactions also arise naturally from the UCTE framework, and their strengths are often linked back to those coherence eigenvalues we talked about earlier. They're all fundamentally effects of how the internal bivector interacts with the local coherence environment.
Okay, give us some key examples. How does UCTE view, say, the Zeeman effect?
Zeeman coupling is the classic interaction of a spin's magnetic moment, S as A, with an external magnetic field. The Hamiltonian is HZDO. This causes the spin to precess around the field lines, that's Larmor rise B, at the Larmor frequency. Iowa standard stuff in magnetic resonance.
Yes. But UCTE as a layer. It interprets the Larmor frequency OL as the temporal projection of the rotor's phase evolution. It's the observable beat frequency emerging from the internal bivector's rotation interacting with the field. And crucially, that U1 eigenvalue related to alpha.
The fine structure constant. It fixes the EM coupling that sets precession scales. So the speed of precession is directly tied back to that fundamental vacuum resonance. It's not just a classical effect. It's rooted in the vacuum structure.
Wow. Okay. What about spin-orbit coupling? That's important for atomic spectra, the fine structure.
Spin-orbit coupling is the interaction between an electron's spin and its orbital motion around the nucleus, HSO, LA, SUTS. It splits energy levels, usually treated as a relativistic correction in standard QM.
But UCTE sees it differently.
Yes. It interprets the spin-orbit energy as occurring where the bivector coherence plane couples to spatial curvature induced by motion through the vacuum substrate.
Whoa. So the electron moving through the vacuum creates a kind of curvature or disturbance in the coherence field, and the spin's internal plane interacts with that.
That's the idea. It's an active geometric coupling between the spin's internal dynamics and the local state of the vacuum substrate, affected by the particle's motion. It's not just a correction term, it's a direct interface with the vacuum structure. And again, higher eigenvalues can modulate these couplings.
That opens up possibilities for maybe influencing that coupling.
Potentially, yes. Understanding the geometric basis might allow for new ways to control it.
Okay, one more big one. Exchange interactions. Crucial for magnetism, chemical bonding.
Exchange interaction is the quantum coupling between two spins, often written as hex JS1US2. The sign of J determines if the spins prefer to align, ferromagnetic J0 or antiferromagnetic J0, leading to singlet or triplet states.
And UCTE's take.
It views exchange as a vacuum-mediated coherence overlap between two local bivectors. It's literally about how the internal coherence planes of the two particles interact and overlap through the vacuum substrate.
So the alignment preference comes from how their coherence fields merge.
Exactly, and the strength and nature of this interaction are shaped by the vacuum harmonics, particularly linked to ESD and possibly higher eigenvalues. It governs how these spins talk to each other through the vacuum.
So all these fundamental spin interactions, Zeeman, spin-orbit, exchange, are reinterpreted as manifestations of the bivector interacting with the vacuum coherence field, modulated by those fundamental resonance eigenvalues.
That's the unified picture. And the same logic extends to other couplings too, like dipole interactions between magnetic moments, hyperfine interactions between electron and nuclear spins, and even things like driven Rabi oscillations. Those are just coherent rotations induced by external fields, which UCTE sees as directly manipulating the bivector's coherent state. It all ties back to the vacuum structure.
This is really building a cohesive picture, tying spin, forces, and interactions back to this underlying coherence vacuum and its resonances. It's powerful. Let's extend this now in part 5 to something maybe more familiar, atomic structure, electron shells.
Right, KLM, shells from chemistry class.
Exactly. In standard quantum mechanics, we get those shells by solving the Schrödinger equation, or the Dirac equation for more precision, right? They come out as stable energy levels.
That's the conventional approach. The shells correspond to solutions with specific quantum numbers, N1, 2, 3, representing allowed energy states where electrons can exist around a nucleus.
But UCTE, again, offers a deeper, more generative view.
It does. It sees electron shells not just as abstract energy solutions, but as resonant phase locks between the vacuum coherence field and the atomic geometry.
So the shells physically exist because the vacuum resonates in specific ways around the nucleus?
Pretty much. They stabilize at locations that act like standing wave attractors within the coherence vacuum. Think of it like pouring sand on a vibrating plate. The sand settles into specific patterns dictated by the plate's resonance modes. Electrons settle into shells dictated by the vacuum's resonance modes around the nucleus.
And the fine structure constant alpha plays a key role here.
An absolutely critical role. Remember, UCTE links alpha directly to that first eigenvalue, E1 1137. And alpha, in turn, sets the Bohr radius, A0, which defines the fundamental size scale of the atom.
Oh, right.
So this shows the entire atomic shell system is fundamentally locked to a vacuum resonance constant. Alpha isn't just a number that determines the size. The underlying vacuum resonance, represented by alpha, dictates where those stable electron shells can form.
So the periodic table structure starts to look like a direct map of these vacuum resonances.
That's exactly the claim. The whole periodic table can be seen as this resonance cascade emerging from the coherence eigenvalues.
Okay, let's trace that. How do the specific shells, K, L, O, M, link to the specific eigenvalues we discussed, U1, SU2, SU3?
It's quite direct in Lilien's framework. The K shell, N1, the innermost shell, is linked directly to the UM1137 plateau. This is the first lock-in radius, setting the basic electromagnetic scale of the atom.
Okay, foundational level.
Then the L shell, N2, holding up to 8 electrons, is linked to the SU2 at 0.125 plateau. This represents the second harmonic resonance in the vacuum. It's associated with stabilizing the spin configurations, Pauli principle, that allow that shell capacity.
Makes sense. SU2 and spin are linked.
Exactly. And the M shell, N3, up to 18 electrons, is linked to the SU3 Orlik plateau. This corresponds to the third shell stability resonance, influencing things like inner shell shielding and how the nuclear charge affects outer electrons. It connects to strong force coherence effects within the nucleus impacting electron structure.
Wow. So it's not just correlation, it's presented as a direct causal chain. Vacuum resonance plateau, specific shell structure and capacity. It explains why the shells are the way they are.
That's the core idea. It provides a reason rooted in fundamental vacuum physics.
But what about the higher shells? N, O, P, Q, and super heavy elements. Standard models often struggle there, right? Things get messy with electron correlations, relativistic effects.
They do get very complex to calculate and predict accurately from first principles and standard approaches. Lots of approximations and computational heavy lifting.
So how does UCTE handle this? Does the eigenvalue ladder continue?
It does. UCTE explicitly predicts higher-order vacuum coherence plateaus beyond SU3, Lilien proposes a 0.5, a 0.66 centimeters, that's able 0.75, epio 0.85, and potentially further.
Higher harmonics of the vacuum resonance.
Exactly. These higher harmonic overtones are predicted to govern heavy elements and manifest physically as the structure of those outer electron shells, N, O, P, Q, and beyond.
And this predicts their capacities and properties.
Yes. What's really striking is that the known electron shell capacity formula, 2n-2, seems to align naturally with this geometric progression of eigenvalues. It suggests a predictive basis for shell structure that standard physics often derives empirically.
That's remarkable. And it might explain anomalies or predict stability for elements we haven't even made yet.
That's a major prediction. This framework suggests new atomic stability bands for superheavy elements, directly tied to hitting these SU4 through SU7 eigenvalue thresholds. It provides a theoretical foundation for the island of stability nuclear physicists search for, predicting where certain configurations of protons and neutrons might become unexpectedly stable due to locking into these higher vacuum resonances.
So the entire structure of the periodic table, its rows, its periods, the patterns, it all maps back to this cascade.
That's the argument. The entire periodic table can be recast as a resonance cascade emerging from coherence eigenvalues. Even the magic numbers in chemistry 2, 10, 18, 36, 54, 86, representing the electron counts for noble gases, the particularly stable configurations. UCTE suggests these numbers match multiplicative resonance locking, reflecting the filling of shells dictated by this eigenvalue cascade.
This basically reframes all of quantum chemistry, doesn't it?
It really does. It suggests quantum chemistry is essentially a subset of vacuum resonance engineering. Shells, capacities, ionization energies, bonding angles, molecular shapes all emerge as consequences of how electrons arrange themselves according to the underlying coherence field eigenmodes set by the vacuum eigenvalues.
It connects the quantum world of particles directly to the chemical world of atoms and molecules through this unifying vacuum structure.
Yes, breaking down the walls between particle physics, quantum chemistry, even cosmology, suggesting they are all different manifestations, different projections of this one fundamental coherence framework.
The scope of this theory is just immense. It's proposing a root-level restructuring of how we understand physics. So let's get into the really big picture now. Part 6. Revolutionary implication and testable predictions. First, what does this do to our understanding of fundamental constants and the forces themselves?
This is where UCTE offers potentially game-changing insights. Take the fundamental constants, like alpha, the fine structure constant, or Planck's constant. In standard physics, they're basically just numbers. Foundational inputs we measure very precisely, but their values aren't derived from theory, they just are.
Right, they seem arbitrary, even if finely tuned.
UCTE argues they are not arbitrary at all. They arise as resonant locks between coherence modes and projection layers. They are essentially the fingerprints of vacuum resonance. Their specific values are dictated by the stable harmonic structures of the coherence vacuum.
So they're outputs of the system, not inputs.
Exactly. And maybe even more profound is the implication for the fundamental forces, strong, weak, electromagnetic gravity. Why these four? Why they're vastly different strengths and ranges.
A hierarchy problem, among others.
Right. UCTE proposes that the entire hierarchy of forces may emerge from one generative equation governed by the vacuum coherence tensor V. This could potentially eliminate the need for lots of fine-tuned parameters or complex unification schemes like grand unified theories.
So one underlying dynamic generating all the sources.
That's the idea. The different forces manifest as different aspects of coherence dynamics, stabilized at different eigenvalue plateaus, SU2, SU3, etc. Their relative strengths and characteristics become natural consequences of this underlying vacuum harmonic structure, not separate phenomena needing ad hoc unification.
That would be the holy grail of physics, really. A true theory of everything emerging naturally. What makes UCTE potentially different from other unification attempts?
I think a key difference is its generative geometric approach, starting from the vacuum structure and the nature of spin. Many theories try to unify forces by going to extremely high energies, assuming they merge there. UCT suggests they are always unified at the level of the coherence vacuum, just manifesting differently based on the resonant states. It doesn't necessarily rely on extra hidden dimensions or unobserved supersymmetric particles in the same way. It's unification through emergence from a common substrate.
Okay, shifting from pure theory to potential tech. What about spin engineering and advanced quantum control? Quantum computing is a huge field right now.
This is where the practical implications could be massive. Because UCTE defines spin geometrically as a bivector projection, It suggests we could potentially manipulate spin with unprecedented precision right at the substrate level where it originates.
Going beyond just shielding qubits from noise.
Way beyond. Current quantum computing relies heavily on error correction to fight decoherence qubits losing their quantum state due to environmental noise. UCTE hints at the possibility of designing qubits that are inherently resistant to noise because they are aligned with the stable coherent structures of the vacuum itself.
Wow, how would that work?
It opens doors to things like custom spin architectures,
Yeah.
where you engineer qubits for maximum stability by controlling that underlying bivector phase plane. Then there's multi-spin resonance design, creating new types of high-fidelity quantum gates by tuning interactions to those predicted higher SU3 plus eigenmodes for more complex computations.
And the ultimate goal?
Perhaps substrate-aligned computing, designing qubits that literally resonate with the vacuum itself. If you could do that, you might achieve coherence, times orders of magnitude, longer than what's possible now. That could be the key to truly scalable, fault-tolerant quantum computers.
A genuine quantum leap, you might say. Okay, what about energy? This is always a big one. Could UCTE lead to new energy sources, maybe tapping the vacuum itself?
This is probably the most speculative, but also the most potentially transformative implication. UCTE proposes the coherence vacuum contains latent energy structured by its harmonic eigenmodes. And crucially, it suggests this structured energy can be coupled, modulated, and extracted under controlled resonance.
So not just random zero-point energy fluctuations, but structured, potentially tappable energy.
That's the critical difference from many conventional ZPE ideas. Because UCTE links this energy to specific, predictable, structured coherence locks, the eigenvalues, it makes the concept theoretically testable and quantifiable. It provides a potential mechanism.
Which is often missing from ZPE discussions.
Exactly. If this is right, it could lead to technologies we can barely imagine. Vacuum-coupled power systems providing clean, limitless energy. Maybe plasma stabilization platforms using vacuum resonance to finally crack fusion power. Or quantum field amplifiers that leverage these vacuum eigenmodes to drastically improve energy conversion efficiencies in existing systems.
That would change everything. Okay, let's go even further out. The paper mentions intelligent architectures and cognitive engineering. What on earth does that mean?
This pushes the boundaries into the nature of intelligence and consciousness itself. UCTE tentatively suggests redefining intelligence, biological, artificial, maybe even consciousness, as fundamentally a form of coherence alignment.
Intelligence as resonance patterns in the vacuum.
Essentially, yes. If thought, learning, awareness are all processes emerging from how information patterns itself and achieves coherence within this fundamental substrate, then maybe we could design new forms of intelligence that resonate at higher order eigenmodes.
So AI that isn't just code on silicon, but is somehow interacting directly with the vacuum's coherent structure.
That's the far-reaching idea. It could lead to concepts like multi-agent coherence networks, where AI agents, maybe even humans, could be synchronized or communicate non-locally through these vacuum coherence channels.
Instantaneous collective intelligence.
Perhaps, or quantum cognitive processing, using these eigenmode structures for new kinds of computation based on non-local inference. Maybe integrated neurotechnologies that tune human brain activity into coherence with machines, or the vacuum itself, potentially enhancing cognition or creating seamless brain-computer interfaces.
Creating intelligent systems, hybrids of human, AI, and substrate intelligence.
That's the ultimate vision Lilien lays out, blurring the lines between mind, matter, and the vacuum field itself. It's deeply philosophical, but grounded in the physics of coherence.
Mind blown. Okay, but this all sounds incredible, maybe even fantastical. A theory needs to be testable. What are the concrete, immediate predictions scientists could actually go out and try to verify?
Absolutely crucial point. And the paper does provide specific, testable predictions. Lilien outlines several experimental avenues. First, precision measurement. Scientists could use high-resolution spin resonance spectroscopy, maybe at ultra-low temperatures and high magnetic fields, to explicitly search for the signatures of those predicted higher eigenmodes, like SU4 and SU5. Finding them would be strong evidence.
Looking for those specific resonance frequencies or energy levels.
Exactly. Second, vacuum energy coupling. Design experiments, maybe specialized resonant chambers, tuned to the geometries predicted by UCTE, to see if energy can actually be transferred from the vacuum under those specific resonance conditions. Look for anomalous energy production locked to those frequencies.
Trying to tickle the vacuum at the right spot to see if energy comes out.
Kinda, yeah. Third, Spin coherence engineering. This involves actually building qubits based on UCTE principles, designed to align with substrate harmonics and then measuring their coherence times. Would they be dramatically more stable, as predicted? That's a direct test of the bivector model in a practical application.
And for
Entanglement geometry tests. Design clever experiments, maybe using systems like nitrogen vacancy centers in Diamond, which are very controllable, to specifically test the UCTE prediction of entanglement as shared plane coherence splitting versus the standard interpretation of non-local collapse. Can we devise a setup that distinguishes between those two pictures of reality?
These sound like real, achievable experiments, even if challenging. They could provide concrete evidence for or against the theory.
That's the key. It's not just philosophy. It makes concrete predictions about measurable phenomena. It lays out a path for experimental verification. That's what makes it compelling as a scientific framework, despite its revolutionary scope.
Wow. Okay, after digging through all of that, it's clear this deep dive into Lilien's unified coherence theory of everything. It's presenting a truly transformative vision.
It really is. It's not just tweaking things around the edges. It's proposing a fundamental, generative reconstruction of the foundations of science.
Asking us to rethink where everything comes from. Spin isn't just intrinsic. It emerges from bivector topology in the vacuum.
Electron shells aren't just energy levels. They're physical manifestations of vacuum eigenmodes, resonance patterns.
Forces, constants, symmetries, they all seem to fall out as projections from this deeper structured coherent substrate, linked by that cascade of eigenvalues.
And even entanglement loses its spookiness when you see it as simply the geometry of a single shared coherence plane being resolved.
It's those connections, those aha moments that really resonate. Seeing how this single framework seems to provide intuitive geometric answers to long-standing mysteries across different fields.
Yeah, bridging particle physics, quantum chemistry, cosmology, weaving them into one elegant architecture. It feels less like forcing puzzle pieces together and more like seeing the original intended picture.
The whole perspective shifts, doesn't it? From seeing the universe as governed by these fixed, maybe arbitrary rules?
To seeing it as this dynamic, nested resonance structure, constantly generating its own reality based on its fundamental harmonic patterns.
It almost changes our relationship with the universe. From passive observers to potentially participants in that generative process.
That's a fascinating thought. If we understand the underlying coherence, could we work with it?
Which leaves us with a really profound closing thought, doesn't it? What if the biggest challenges we face in fundamental physics and developing truly advanced technologies like quantum computing or clean energy, maybe even in understanding intelligence and consciousness?
What if the solutions lie in understanding and maybe even aligning ourselves with this hidden geometry, this coherent structure beneath reality?
It suggests a future where scientific and technological progress isn't about fighting against nature's limits, but about finding harmony with its deepest, most fundamental, coherent principles. Like learning to conduct the universe's symphony instead of just listening to it.
A truly exciting and perhaps humbling prospect.
Definitely something to mull over. We really encourage you, our listeners, to keep asking questions, keep exploring these ideas, because this journey into the coherence vacuum, well, it feels like it's only just beginning.